Hello everyone, it's Mr. Wolf here, and in this video I am going to be modeling the thinking process for number 6. So you see a person who ran out of gas on the road and is trying to push their car to the gas station just 100 feet away. When you come over to help, the net force on the car is now 3 times as much. All right? So which other variable besides net force is changing? So here is my equation. Net force is equal to ma. We know that the net force has increased in this case. But then is it mass or acceleration that's also changing? Well, let's think about the object that's being pushed. It's the car. So by you coming over and helping out push the car, that's not changing the car's mass at all. So the mass must be the same. So then it has to be acceleration that's changing in this case. Now, this is all we need for this answer, but I just want you to be thinking about this in your head. If my net force goes up because acceleration's on the opposite sides of the equation, we know that they're directly related, then we also know that acceleration should be increasing in this case. And that kind of intuitively makes sense. So now, by what factor is the variable we identified? So acceleration, different. So we got to show our work. So net force is equal to mass times acceleration. All right. I know that my net force in this case is 3 times as much. So I'm going to put a 3 here. I know the mass of my car hasn't changed, so I'm just going to put a 1 in. And then my acceleration, well, that's what I'm looking for to see how much it changed by. And the math on this is pretty easy, right? In order for this equation to work out, my acceleration has to also be, my net force is 3 times as much, my acceleration is 3 times as much. So remember, this is just our factor of change right here. It does not mean your acceleration is 3 meters per second squared. It just means it's 3 times as much. But now that we have this value, right, what we want to do is actually calculate the new value for the acceleration. So I'm, again, given 2 values. This one's in newtons, so this is my force. This one's in meters per second squared, so this is my acceleration. If I'm trying to see how my acceleration changed by, I want to use my variable or my number that is acceleration. So 0.02 meters per second squared. Right? I guess I don't have to have the units. This is my original value. And then what I'm going to do is I'm going to multiply that by my factor of change, which we calculated to be 3 times as much when we increase the net force by 3 times. So 3 times 0.02 is going to give me a new acceleration of 0.06 meters per second squared. Right? And since there's no negative or anything else, I'm just going to, and it's a positive answer, I'm going to assume that this acceleration is going towards the right.